Okay, what I'm going to do now is give you a few minutes and see if you can fill that in. Okay, and then I'll go through. You've received all of the information to be able to do that, so I want you to give that a try. Let's see what the answers are here. Okay, the value of the slope. Anyone? Ruth? What do you think the value of the slope is?
Was it 2581?
Yep, actually it's 28582, but close enough because we need to round up. Okay, so what we want here is the thing that's trying to explain the other thing. Well, first of all, what percentage are we going to put in there? 31 is correct, 31%. Okay, so what is it we're using to explain? Exactly. Hours of television watched explains 31% of the variation in, and that's the other one, which is household debt. Now, this may seem really trivial and actually quite babyish the way I'm doing it, but believe me, it is really, really hard to interpret these things unless you have a structure. For years I've taught this stuff and people find it very difficult to work out which way round things are going. So I thought a way to teach it was to give you this template so that you can have this way that you can be sure that what you're saying is sound. So you can try and say other things as well as you like, if you like, but this means that whatever you say is actually statistically okay, so long as you get things the right way round. Okay, so using a 95% confidence level, we can say that, I mean, it's a bit cryptic to work out what it is, but what we're going to say is that household debt, so this is the thing that we're trying to predict. Okay, is it going to increase or decrease? Okay, is the slope positive or negative? It's positive. That means that the household debt is going to increases by between $2213 and $2950 for each hour of television watched per week. Okay, so there we've interpreted the confidence level. We've also given a better idea of what that 2582 is. Okay, the p-value for the test of whether the coefficient is different from 0 is, what was the p-value? Was 0.000. Okay, now it is actually important to put decimal places in there. If you just put 0.0, people don't know what level of precision you're going to. So putting 2 or 3 decimal places is good because it shows that it's 0 to that many decimal places. Because I mean that could be 0.0004 rounded down, but it isn't. Okay, now here, what kind of evidence do we have? If we have a p-value of 0, okay, you've got a choice of strong, moderate or weak evidence. Put up your hands if you think that is strong evidence. Put up your hand if you think it is moderate evidence. Put up your hand if you think it's weak evidence. Well, we've only got one person who has any idea. Okay, let's think about it. What we're trying to do is get rid of the null. Okay, what do we have to have? What does our p have to be for the null to go? Pardon? No. What's the little rhyme? P is low, null must go. Okay? So in a way, if P is lower, null is even goer, sort of. So the lower your P is, the smaller your P is, the more evidence you have that this is not, that the null hypothesis can't possibly hold. Like you say, you know, when I did the pinky bars and I took out 4 pinkies in a row, you think, well, that doesn't look as if there's anything else. It looks as if there's more than a third pinkies in that bag. Okay, if I'd taken out 17 and they were, you know, in a row and it was always pinkies, you've got more and more evidence because the probability of that happening, if in fact there was a third pinkies in there, is really, really, really small. And so that means we've got more evidence. So we have strong evidence. So well done, that person. Strong evidence that household debt is related to hours of television watched in the population. So important things in there. Notice it only says related, it does not say caused by, and it also says in the population. We know that there is this relationship in the sample. From it we're inferring that we're pretty sure that there is evidence that there is a relationship between the two. Okay, now the next slide is just put in here for completeness really, because it's good for you to know how things are written mathematically as well. And in fact, if you'd been taught by the person who taught this last year, this is what they begin with. Mathematicians do it the other way around from what I do. They start off with the math stuff and tell you all the maths, and then they tell you how to apply it, whereas I think it's better to start with what does it actually mean and then throw in the maths at the end if you have to. Okay, so you have this idea there's a relationship in the population, so it might be that debt equals constant plus something times the number of hours of television plus some natural variation. That's what we're saying. Or it could be that we're trying to predict someone's height, and one year we collected height data from the students, from their height, their mother's height, their father's height, their age and their sex. And then we tried to see what is the best way of predicting a person's height, how well can we predict it. So we could have constant, so that's like maybe 5 foot, plus some other value times the mother's height, plus the natural variation, because people are different heights, even if you take into account the explainable variation, which is how tall their mother is. And in fact, the mother's height is actually the best predictor of a person's height, and just about every son is taller than their mother. In fact, I've yet to find an example where this is not the case. So boys, if you want to have basketball children, you need to marry a tall wife. Mind you, there's probably some correlation there, because generally men don't marry women who are taller than them because it feels scary, and so there's a relationship between the male height and the female height, so who knows. Okay, price of car, another one we've done before, is it is a constant value, like some sort of intercept value, plus some other value times the age of the car. So each year, in fact, that value there would be a negative value, because as the age gets bigger, the total price will get smaller. So that some value would be a negative coefficient. And the slope, because if you imagine the price of a car, the slope goes down. Okay, so here we've got the thing we're trying to explain. And then we've got what's called beta naught, that's the constant or intercept. And then we have the coefficient of x. And when we're talking multiple, you have lots of b's. You have beta 1, beta 2, beta 3, beta 4, depending on how many things we're using to predict with. We've got eta, I think it is, which is your natural variation, and we just can't get rid of that. And then this thing here, the x, is what we are using to explain. So we use data from a sample with certain assumptions. There's a whole lot of things about residuals being independent and normally distributed and stuff like that, but we're not going to worry about that this year to estimate that equation or model.